So hello everyone. So today in this video we are going to solve this problem from CSES problem set that comes under the sliding window section and goes by the name sliding window cost. So let us start with this problem now. So in this problem you are given an array of n integers and your task is to calculate for each window of k elements from left to right the minimum total cost of making all the elements equal. So you can increase or decrease each element with cost x, where x is the difference between the new and the original value, and the total cost is the sum of such costs. So in the input, the first line contains two integers n and k, that is the number of elements and the size of the window, and then there are n integers from x1 to xn, that is the contents of the array. And in the output you have to output a total of n minus k plus 1 values, that is the minimum total cost for each window. And here are the constraints in which k and n can be as high as this, and the value of each element can go up till 1e9. So this is a given input and here is the expected output, right? So this is the overall question here. So the problem is asking you a simple thing, that for each window you have to calculate the minimum total cost of making all the elements equal. And in order to make all the elements equal, you can either increase or decrease each element by a fixed value, right? So in order to understand this problem better, let us move forward and try to understand this given example even in more depth here. So this is the given input here. So in this given example here, the size of the array is 8 and the size of the window is 3. So there are total of 8 elements present in this range from 1 to 8, and since I want to use 1 based indexing, so I have added a dummy value here at the 0th index here, right? So since the value of n and k are 8 and 3, so the total number of fixed windows will be n minus k plus 1, that is 8 minus 3 plus 1, that is 6. So total of 6 different windows are present here that I have marked with different colors, and on top of that I have written their expected outputs as well, right? So this is the first window, and for this window here the expected output is 2. Similarly for the next window of size 3 the expected output is 2, and again for the next window the expected output is 5, and so on till the last window. So what is our goal? So our goal is very simple, that for each window what we have to do is we have to bring all the elements either down or up to a common value, right? So suppose if this was our window here, that is 2, 4 and 3, then we have to make all the elements equal for this window. So suppose I want to make all the elements equal to either 2 or 4 or 3. So if I want to make all the elements here equal to 2, then what I will do, I will simply decrease the value of this 4 by 2 in order to get it equal to 2. Similarly, I will decrease the value of this 3 by 1 in order to get it equal to 2, right? So since here I am decreasing this 4 by a unit of 2 and here I am decreasing this 3 by a unit of 1, so my total cost will be 2 plus 1, that is 3. So I can say that the total cost of making all the elements equal here, and that equal value is equal to 2 here, so in that case my total cost will be equal to what? So it will be equal to 3. So in this way the total cost will be calculated. Similarly, what other thing could we have done is, we could have bring all the elements equal to 3 here, right? So to do that we would have increased this 2 by 1 value to make it equal to 3, and we could have decreased this 4 by 1 in order to make it equal to 3. So 1 plus 1, that is equal to 2, right? So in this way now our total cost is equal to 2 to make all the elements equal to 3, right? And since this 2 is less than the previous cost, so that's why I can say that the total minimum cost as of now is equal to 2. And the same thing you can try for this 4 as well, that is to make all the elements equal to 4. And to do that you have to increase this 2 by a unit of 2, and you have to increase this 3 by a unit of 1, that is 2 plus 1, that is 3, which is obviously not less than 2. So that's why I can say that the total minimum cost of making all the elements equal for this window is nothing but just a 2, when every element would be changed to 3, and in order to do that I will increase it by 1 and I will decrease it by 1. So that's why 1 plus 1 equal to 2 would be the total minimum cost to make all the elements equal for this window. So our objective is very simple now, that is we want to make all the elements equal by increasing or decreasing their values, right? And the cost of increasing or decreasing it will be added to the total cost. So to understand the same thing even in more depth, consider this array here. So suppose this is the window, right? So suppose this is a k sized window or 4 sized window of any given array consisting of elements like 3, 7, 5, 1. And our task is to make all the elements equal such that our total cost will be minimum. So how we will do this? So now we know that either we can make all the elements equal to either 3 or 7 or 5 or 1, right? Because these are the only 4 elements present in this window, that is the 4 distinct elements. So we can make all the elements equal to either this 3 or this 7 or this 5 or this 1, right? What I have done here is I have considered all these different 4 cases and tried to evaluate the total cost one by one. Let us see what will happen if we do this one by one. This is the first case in which I have tried to bring all the elements of this window equal to 3. So if we try to bring all the elements of this window equal to 3, then what will happen? So if I want to bring all the elements equal to 3, then in that case this 3 will remain as it is, but this 7 will decrease by a certain value, this 5 will decrease by a certain value, and this 1 will increase by a certain value, right? So to make this 7 equal to 3, I have to reduce this 7 by how much value? By a value of 4, which is nothing but this 7 minus 3. Similarly, to make this 5 equal to 3, I have to reduce this 5 by a value of 5 minus 3, that is 2. And similarly, to make this 1 equal to 3, I have to increase this 1 by a certain value. So what is that value? It is equal to this 3 minus 1, that is 2. So since I am doing a 3 operations here, and this is the cost of doing each one of them, so the total cost here is equal to 4 plus 2 plus 2, that is 8. So I can say that the total cost of making all the elements equal for this particular window here, when I am bringing all the elements equal to 3, is nothing but 8. So this is our first case. So let us now see our second case, in which we will try to bring all the elements equal to 7, right? So we are done with this 3 now, in which the total cost is 8. So now we are trying to see what will be the total cost for this 7. That is, now we want to bring all the elements equal to 7 now for this window. And in order to do that, we have to increase this 3 by a certain value. This 7 will remain as it is. We have to increase this 5 by a certain value, and similarly increase this 1 by a certain value. So we have to increase this 3, increase this 5, and increase this 1. So in order to increase 3 by a certain value, so that value will be nothing but this 7 minus 3, that is 4. Similarly, to increase this 5 and reach it equal to 7, the difference would be 7 minus 5, that is 2. And similarly, to make this 1 equal to 7, the difference would be 7 minus 1, that is 6. So the total cost in this case will be 4 plus 2 plus 6, that is 12. So I can say that to make all the elements equal for this window, when I want to make every element equal to this 7 only, then the total cost will be equal to 12, right? So this is my second case, and obviously this 12 is greater than the previous result, which is 8. So as of now, our minimum cost is nothing but 8 only. So this cannot be our answer anymore, right? This may be or may be not our answer, but we will only be sure about this after solving these remaining 2 cases. Got it? So that's why let us now see our third case here, in which we will try to bring all the elements equal to 5. So in order to bring all the elements equal to 5, what we have to do? So we have to increase this 3 by a value of 2. We have to decrease this 7 by a value of 2, and this 5 will remain as it is, and we have to increase this 1 by a value of 4, right? So we have to increase this 3 by a value of 2, we have to reduce this 7 by a value of 2, and we have to increase this 1 by a value of 4. So the total cost will be 2 plus 2 plus 4, that is 8. So this is the total cost of making all the elements equal to what? Equal to 5, right? And since this 8 is the same as this result, so I can say that as of now our total minimum cost is again 8 only, and it is not reduced further. And after that we will try our last case, that is we will try to bring all the elements equal to this 1, right? Because we have tried out these 3 possibilities, and now This is the only remaining distinct element, so we will try to make all the elements of this window equal to 1. And in order to do that, we have to decrease this 3 by a value of 2, we have to decrease this 7 by a value of 6, we have to decrease this 5 by a value of 4. So we have to reduce each one of them. So we have to reduce this 3 to bring it equal to 1, that is 3 minus 1, similarly 7 minus 1 and 5 minus 1. So this will be equal to 2, this will be equal to 6, and this will be equal to 4. So the total cost here will be equal to 2 plus 6 plus 4, that is this, which will be equal to nothing but 12 only. And since this 12 is greater than the minimum cost as of now, so it means that this case cannot be our answer. And finally, I can say that out of all the total costs that I have calculated here, the minimum one is nothing but 8 only. So that's why I can say that the total minimum cost of making all the elements equal for this window is nothing but 8. So we have to print 8 as our answer. So after we have done this calculation, I want you to realize one thing, that what has happened actually. Since this is our current window, that is 3751, and when this window will be sorted, then it will look something like this, that is 1, 3, 5 and then 7. And since we saw that we got the total minimum cost equal to 8 for two different cases, that is case 1 and case 3. So this 3 and 5 are nothing but actually the median of this window, right? So when this window will be sorted, it will look like this, and in this window you can see that these two middle elements, because since this is an even sized window, so there will be two median elements, right? In case it was an odd window, then there would have been only one median element, but since this is an even window, so that's why there are two median elements. And we can see that for these median elements, the total cost is minimum out of all the possible elements, that is 375 or 1. And this is not a coincidence, because this is a complete mathematics. So if you try to deviate, that is you try to calculate your answer of minimum cost for any other element apart from this median values, that is either 7 or 1, then definitely the total cost that you will get will be more as compared to these median values, right? Because these median values are trying to balance everything. And even in that case, when the number of elements in the current window will be odd, then we know that in that case there will just be a one median element. And you can try on your own to see that that one median element present at the center of that odd sized window will be the one which will consist of the total minimum cost. So that will be the only element in that case that will consist of the total minimum cost. But since here are two medians, so that's why two different same costs are present here, which are nothing but the minimum only. So that's why I can say that if we know the median, which we know from the previous video as well, then we just have to calculate the absolute difference of every element of the current window with this median for the current window, right? So once we know that the median of the current window will be 3 and 5, right? So according to previous video, we have learned to calculate it the lesser value, that is 3. And since the total minimum cost is same for 3 as well as 5, so it means that we can work out with any one of them. So we will try to choose this 3 because we already know how to calculate it. So once you know 3, your only task will be to take the absolute difference of this 3 with each and every value of the current window. That is 3 minus 3 plus 3 minus 7, or 7 minus 3 plus 5 minus 3 plus 3 minus 1. So if you are able to calculate the absolute difference of this median with each and every element of the current window, then whatever answer you will get, it will be nothing but the total minimum cost of that current window. And this is what we want. So now if I tell you, then our only task is to calculate the absolute difference of the median with each and every element of the current window, right? So how can we do this efficiently? So let me tell you this here. So since we know that when we will be calculating the median of the current window, so since this is our current window here, so its median will be calculated in such a way that at last the left and right multisets will look like this, right? Because since the number of elements here are even, so two elements will be present in this and two elements will be present in this. And since in sorted order the elements are like 1, 3, 5, 7, so they are present in this order only, that is 1, 3, then 5, 7. And out of this one is my median element, which is present at the top of the left multiset. So now what I want, I have the median here equal to 3, and I have these two multisets ready with me. So I just want the absolute difference of this median with each and every element present in the current window. That is the absolute difference of this 3 with all the elements present in this and all the elements present in this. That is, I want 3 minus 3, that is subtract this 3 with itself plus this 3 minus 1 plus this 5 minus 3 and then this 7 minus 3. So I want just this result to be computed easily. And if you try to rearrange the terms here, then carefully see what I am doing here. So I will try to rearrange these two terms that belong to the right multiset as of now, that is 5 minus 3 and 7 minus 3, into this, in which I have written this 5 plus 7 together and then this 3 plus 3 together. So what is this 5 plus 7 here? So it is nothing but the summation of all the elements present in the right multiset, right? And what is this 3 plus 3? So this 3 plus 3 means that we are subtracting 3 twice. And why we are subtracting twice? Because there were two elements present in the right multiset, that is 5 and 7. So because of that we had to subtract this 3 twice. So I can say that this 3 plus 3 will be nothing but this median here into the size of the right multiset. So since there are a total of two elements in this right multiset, so I will say 2 into this 3, that is 6, which is nothing but this only, that is 3 plus 3 equal to 6. So I hope this is clear why this is 3 plus 3 here and what does it mean. So let me again tell you if you have not understood that what I just told. So our goal now is to calculate the absolute difference of this median with each and every element. That is 3 minus 3 plus 3 minus 1 plus 5 minus 3 plus 7 minus 3, right? First I am explaining you this right multiset concept here. So since this is the right multiset terms, that is this 5 minus 3 and 7 minus 3, so I have just rearranged these two terms into this. That is, I have written this 5 plus 7 together and this 3 plus 3 together. So this 5 plus 7 is nothing but the summation of all the elements of this right multiset. And this 3 plus 3 is coming twice because we have subtracted this 3 twice. And why we have subtracted it twice? We have subtracted it twice because twice was the number of elements for this right multiset. That is 2 into 3. So that's why what I can say that this term is nothing but the summation of right multiset minus the median into the size of the right multiset. So since the median was 3 and we are subtracting it twice, so that's why 2 into 3, that is 6. So that's why instead of writing it like this, what I can write it like, I can write it like 2 into this 3, so that it would be more meaningful to you. And now I hope that you have understood how I have written these two terms here into this and what does it mean actually. The same thing I will do for this left multiset as well. So since I want the absolute difference of this 3 with each and every element in this multiset also, that is 3 minus 3 and 3 minus 1, right? So 3 minus 3 and 3 minus 1, that is these two terms. So again, if I try to rearrange these terms, that is I will try to write this 3 plus 3 together and this 3 plus 1 together here like this. So what is this 3 plus 1? So this is nothing but the summation of all the elements present in the left multiset, that is 3 plus 1. And what is this? This is 3 plus 3. And why is it coming twice? So it is coming twice because we are subtracting this 1 from this 3 first and then this 3 from this 3 first only. That is, we have to subtract these two elements from the median twice. And why we have to do that? Because there are twice number of elements present in the left multiset. So that's why we need to use this 3 twice. So that's why it is coming here 2 times. So again what I can say is I can simply write this 3 plus 3 as nothing but 2 into 3. So I can write it like this. That is, since I am using this 3 twice here in order to subtract this 3 as well as this 1, that is I am doing a 3 minus 3 and then 3 minus 1. So I have written these two terms here which are getting subtracted here like this. But since I am using a 3 here twice, that is this 3, and we are using it twice because two elements are present, right? So we are using twice what? This 3. So that is equal to 2 into 3, and so that's why I can say that this 2 is nothing but the size of the left multiset and 3 is nothing but the median. So that's why I can say that this formula here, or rather this calculation that we needed to do at the very first stage, is now simplified to this formula. That is left dot size into median minus summation of left multiset plus summation of right multiset minus right size into the median. And If you put every value in this formula, then you will ultimately get the total cost that you need, which will be our nothing but the total minimum cost. And since from the previous video we know this median very well, right? And also just by doing this left dot size and right dot size, we can at any time get the size of the left and right multisets as well. So now our only task is to make sure that we know the summation of left multiset and the summation of right multiset at any time, right? So if we are able to keep a record of these two variables, then we will simply use this formula in order to calculate the total minimum cost of any window. So I hope you have understood what is the logic behind all this, right? So let us now move forward, and here, to know the summation of each multiset, we will do nothing but we will just maintain two variables, that is the summation of left multiset, which will be equal to 0 initially, and the summation of right multiset, which will be equal to 0 initially. So every time we will insert a value into the left multiset, we will increase the value of this SL by that much value, right? And every time we erase a value from the left multiset, we will decrease this SL value by a certain value, right? So if you are inserting, so let me tell you, so if you are inserting, let's say 1 into the left multiset, so I will just increase its value by 1 like this. Similarly, if I am erasing the 3 from the left multiset, so I will just decrease it by this. Similarly, if I am inserting a value of 5 in the right multiset, so I will increase it by this much. And similarly, if I am erasing a value from right multiset, which will be equal to 7, so I will erase it like this, that is I will decrease its value from the variables like this, right? So you just have to play with these variables in order to maintain the sum. So initially this variables will be equal to 0, as currently or initially there will be no elements in the multisets, but as we will move forward and insert or remove the elements, so we will maintain the sum like this. So let us now handle our very first window, right? So I will not tell you how to calculate the median because I have already told you that in the previous video. So in this video I will only do the calculation after calculating the median, right? So this is our first window, and now we know that after traversing through these elements, this will be the status of our left and right multiset, and this will be our median, that is the median will be 3. And since the elements that will be present in the left multiset will be these 2 and 3, so I can say that the summation of the left multiset will be equal to 5, that is 2 plus 3. And similarly the summation of the right multiset will be equal to 4, that is SR value will be equal to 4, because only one value is inserted into this right multiset. So now since now we know the median of the current window, which is equal to 3, and we want to determine the total minimum cost. So we know that instead of doing the absolute difference of this median equal to 3 with each and every element directly, we will simply use this formula, right? That is left dot size, which is equal to 2, right, into the median, which is 3, minus the summation of left, which is maintained in this variable, which is 5. So 2 plus 3, that is 5, plus the summation of right, which is this, that is 4, minus the size of right, which is 1, so 1 into the median, which is 3. So if you just put out the values of these variables, you will get this expression, and by solving it you will eventually come to this 2, right? So that's why I can say that the total minimum cost for this current window will be nothing but 2, and that's why in the expected output also for the first window the expected output is 2. So you just have to print this, and in this way we will be handling our very first window. So let us now move forward and try to play with the remaining windows. So this will be our second window, right? And in this second window, after the median will have been calculated, this will be the status of my left and right multisets, and this will be my median, that is 4, and the summation of left multiset will be equal to 3 plus 4, that is 7, and the summation of right multiset will be equal to 5. And now again, if you want to determine the total minimum cost of the current window, then we know its median, and we also know the value of SL and SR, right? And we also know the size of left and size of right. So you just have to put the values of these variables here, and after putting these values here, again you will see that the total minimum cost of this window is 2. So again you will just print a 2 here, and in this way our second window will also be completed. Now let us move forward and see what will be the case for the third window. So this will be our third window, and after calculating the median of the third window, this will be how the left and right multisets will be looking like, in which 5 will be my median. And since I know the median now and also the value of summation of left and right multisets which are both equal to 8, that is 3 plus 5 and 8. So now you know the left size which is equal to 2, you know the median 5, you know the summation of left equal to SL equal to 8, and also you know the summation of right, that is 8, and the size of right which is 1, and this median equal to 5. So just by using this formula here, you will get the result equal to 5. That is the total minimum cost of making all the elements equal to this 5 will be equal to this 5 only. So we'll just print a 5 for the third window. And now again we will move forward and try to see the result for the fourth window. So this will be our fourth window, and after calculating the median, we will get the median, it's equal to 5. And this is how the left and right multisets will be looking like, and this will be my variables for the summation of left and right multisets. So for the left it is equal to 1 plus 5, that is 6, and for the right it is just equal to 8 here. So the total minimum cost will be equal to again this formula only. So the left size is 2, the median is 5, the left summation is SL equal to 6, and the summation of right is equal to just 8, which is this SR. The right size is 1 and the median is 5. So by putting these values here, you will get equal to 7. So you just have to print a 7 here. So this 7 is the total minimum cost of making all the elements here equal to 5. And why we are trying to change all the elements equal to 5 only? Because this 5 is the median of this window. Because when this window will be sorted, it will be equal to 1, 5 and 8. So this 5 will be present at the middle. So that's why if we try to change this every element equal to 5 only, then in that case only the absolute difference summation with all the elements to a particular element will be minimum, and here it will be equal to 7. And you can try to think of any other case here as well. So if you try to change every element here equal to, let's say, 8 instead of this 5, then in that case you have to increase this 5 by a value of 3, and you have to increase this 1 by a value of 7. So 3 plus 7 equal to what? So 3 plus 7 equal to 10. And this 10 is definitely greater than 7, so that's why 10 cannot be our possible answer. So that's why not every element should be converted here to this 8. And again we can try the same thing for this 1. So that's why if we try to change every element equal to 1, then in that case you have to bring this 5 by a value of 4 and bring this 8 by a value of 7. So 4 plus 7, that is 11, right? So again this 11 is very much greater than this 7. So that's why other than this median value, that is 5, you cannot select any value neither on the left or the right part of the median, because they will always give us more answer than the median one. So that's why selecting median is the only feasible option. So that's why 7 will be the answer for this fourth window. And now let us see the answer for the fifth window. So this will be our fifth window, and after calculating the median, this is how the left and right multisets will look, and 2 will be my median. And this will be my summation maintained for the left and right multiset, that is 3 and 8. So again, after putting the values here, the left size will be equal to 2, the median is 2, the summation of left is 3, the summation of right is 8, the right size is 1, and the median is 2. So after putting these values, you will again get a 7. So the answer for the fifth window is 7. And now let us see our last window here. So this will be our last window, and after processing the last window, this is how the left and right multisets will be updated like. So in this, the median will be 1, right? So the median of the last window is 1, and also the summation maintained for the left and right multisets will be 2 and 2 only, that is 2 for this and 2 for this. So after putting these variables value here, the left size is 2, the median is 1, the summation of left is 2, that is SL, the summation of right is 2, that is SR, the right size is 1, and the median is 1. So after putting these values here, it will be equal to 1. So that's why I can say that the answer for the last window here, that is the sixth window, is equal to 1. That is, to make all the elements here equal to what? Equal to 1. We just have to do a cost of 1. That is, we just have to reduce this 2 by a value of 1 so that every element will become equal to 1. So that's why selecting the median is the most feasible option in any window. So that's why this is how the sixth window will be handled. And in this way we printed these integers, that is 177522. So 177522 and 2, and this was our expected output also, if you see. So 177522. So I'm just reading it from the backward. right? So this is the whole logic behind this problem. So our goal was very simple, that we just wanted to make every element equal for a given window, and in order to make all the elements equal, we had options that we can make all the elements equal to any element, but we tried to choose that element for which the total cost will be minimum. And by doing a hit and trial method, or you can also realize it using mathematic variables only, so you will realize that the most feasible option was to select the median value, because by selecting the median value only, the total cost will be minimum. And since in this example given the window size was odd, so we knew that there can only be one median element, and by selecting that median element and taking its absolute difference with each and every element, we can get our answer easily. So our only task was to make sure that we calculate this absolute difference in the minimal possible way, right? And in order to do that, we derived this formula by rearranging the terms, and we realized that if we are able to maintain the summation of left and right multisets, then we can simply use this formula in order to get our result, right? So we just did that. We just maintained two variables in order to maintain the sum. So every time we are inserting an element into the set, we will increase its value, and every time we will erase an element from a set, we will decrease its value, right? So this is how all the windows were handled, and we were able to get our answers, right? So now let us see our code and see how it will look like. So first we will take the inputs of this n and k, then we will take the input of the array here, and then here I have declared two different multisets, left and right. So this is the exact similar code of the previous problem. I just have maintained two different variables here, that is SL and SR, to maintain the summation of the left and right multisets. So every time we are inserting a value in the left multiset, I am also increasing the value of this SL, as you can see. Similarly, every time I'm inserting a value in the right multiset, I am increasing the value of this SR, right? And after the window has been completed, we know that our median is stored in this. So here I have initialized a variable of cost equal to 0 initially. So we know that our cost for the first window will be equal to this formula. So I have broke down that formula into two parts, that is first for the left multiset part, and then another for the right multiset part, so that you can understand better. So that the cost will be equal to this, and then I will add the cost of the right multiset. So this is the same formula here, that is the left dot size into this median minus SL variable, and then again I will add it to this cost, that is SR, that is summation of right, minus median into right dot size, and whatever the cost will be there at this end, we will simply print that. So this will give us the cost of the first window, and this is for the remaining windows. So every time we are inserting an element in the left, we will increase the value of SL, and every time we are inserting an element in the right, we will increase the value of this SR. Similarly, every time we are erasing a value from left, we will decrease the value of this SL, and every time we are erasing an element from this right, we will decrease the value of this SR. And after calling the rebalancing function, we will get our median, which will be stored at this part, that is the top of the left multiset. So again our cost will be equal to, first I will make it equal to the left multisets calculation, and then I will add the cost with the right multiset, that is SR minus median into right dot size, and whatever cost will be there, it will be our total minimum cost of making all the elements equal for the current window to its median value. So we'll simply print that, right? So you can also write this formula into a single line, but I just wanted to write it in different lines so that you can understand better. And if you remember, then this is our rebalance code. So in this also I just have done one thing, that whenever I am inserting an element on the left, I will increasing the value of this SL by that much. Similarly, whenever I am erasing a value from the right, then I am simply decreasing the value of this SR. Similarly here also, that whenever I am inserting a value in the right, I am increasing the value of this SR, and whenever I am decreasing or erasing the value from the left multiset, then I am simply decreasing the value of this SL by that much. And that's why, to make sure that this summation of left and summation of right variables are properly passed, I have passed here by reference, so that after doing the changes here, it will reflect it in this formula correctly, right? So this is the whole logic behind this problem. So it is just using the median concept from the previous problem. The only difference was that we need to understood that why selecting median element is feasible for this current problem, and how we can maintain the summation of left and right multisets effectively in order to put in this formula and calculate the cost. So I hope everything is clear and that you have understood this problem correctly, right? So yeah, This was pretty much about this problem. So yeah, thank you so much for watching this video. Thank you.